Hey Chemistry, Mrs. KJ here, going over 3.01, and Unit 3 is all about the periodic table. The periodic table is one of the most important tools in the study of chemistry. This unit will explore aspects of the periodic table from the discovery of the elements and early attempts at arranging them, to the properties exhibited by the elements, to specifics about the different groups of elements. And so here they just show some of the original symbols that they gave to the elements that they knew about far before they knew a lot about the atoms. And you'll notice there's some things on here that aren't elements, such as potash, soda, lime, and they don't mean like soda pop. They mean the mineral soda. But some of them are, like sulfur, phosphorus, oxygen, carbon, hydrogen. So lesson 1, atomic number and the periodic law. The modern periodic table is arranged according to atomic number. In this lesson, you will learn about the historical background of the periodic table. You will see how early chemists arranged the elements in a periodic table, and then take a quick look at the arrangements of elements in the modern periodic table. Goals for this lesson: explain the historical discovery of recurring patterns of properties with increasing atomic mass. This is huge. Okay, so let's say it again. The fact that there's recurring patterns of properties of the different elements, and it has to do with the fact that their mass is increasing as you go up in atomic number as well. And then define periodic law. Elements have been organized by periodic law based on atomic mass, developed primarily by Mendeleev. All right, so you can get your student guide. Organizing information into understandable patterns makes it easier to access that information. Think about the last time you went to the mall in search of a new pair of basketball shoes. Did you go into a store that specializes in sports clothing and shoes? Or did you shop at a large department store? In either case, you used your knowledge of how things are organized to find the perfect pair. Some stores sell only one kind of product, such as sports shoes or men's shoes. Large stores are organized into departments where products with similar characteristics are grouped together. If it doesn't make sense, try imagining a department store where products are arranged by color. Red towels, red ties, and red tennis shoes are side by side. You'd have to walk all over the store to find and compare different colored basketball shoes. So that's why all the shoes are in one department. So classifying and organizing objects and information makes basic tasks and scientific work easier. Chemists also arrange information in a predictable and regular manner. You have perhaps seen a large, colorful, rectangular chemistry chart called the periodic table that shows the elements and their atomic number, symbol, and average atomic mass. Elements with similar chemical properties are grouped together. The periodic table is the primary tool for seeing the organization of the chemical elements. So these aren't put up on here randomly, and it's not just because of atomic number going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which it does do, but there's a reason that they're each in certain columns and why hydrogen as number 1 is over here and helium as number 2 is over here. Chemists have developed logical, useful ways to organize elements on the basis of their properties and composition. The periodic table is one of the most common and effective ways to do this. Mendeleev was the first person credited with arranging the elements into an early periodic table. All right, so let's check out when this happened. And, all right, so we have Mendeleev, and it was right before the 1800s, and you can see that that's important because, right before the 1900s, and that's when a lot of work with atoms started. So he arranged a periodic table before we really knew a lot about the atoms. And there were other people who tried organizing based on physical properties. Dalton organized the elements he knew, but we've stuck with Mendeleev's because he introduced groups, in other words, columns going down, and periods, or the rows, going across. And we'll talk a lot about those. In the 18th and 19th centuries, a number of scientists attempted to categorize the elements into groups based on the elements' chemical and physical properties. In 1869, a Russian chemist named Dmitry Mendeleev successfully organized the elements into a single table. He developed his table by placing all the information about each element onto cards, and then rearranging the cards until logical patterns emerged. Other chemists had developed lists of elements arranged by atomic mass, which Mendeleev used. He organized the table into 8 columns and 12 rows, according to known trends or patterns among the elements. Much of Mendeleev's data revolved around the atomic masses of atoms of an element. Therefore, the table was arranged that way. Mendeleev arranged his periodic table into groups and periods, or in other words, columns and rows. Mendeleev's table had 8 columns called groups. The group headings in the periodic table reflect elements with similar properties. The groups on Mendeleev's periodic tables were labeled 1 through 8 in Roman numerals. The table also contained 12 horizontal rows or periods. Mendeleev organized the table according to certain trends in properties of the 60 elements that were known at the time. He recognized that certain physical properties repeated about every 8th element. For instance, lithium and sodium have similar properties, as do calcium and silicon. All right, so he put the elements on cards, and then he said, oh, okay, so I do lithium, and then beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And he got to sodium, and he's like, whoa, sodium's a lot like lithium. I'm going to put it underneath. And he got to magnesium, he's like, oh, look at this. Magnesium is a lot like beryllium. Aluminum's a lot like boron. Well, silicon sure is a lot like carbon. Oh, phosphorus has a lot of the same properties as nitrogen. Well, look here. Sulfur reacts the same as oxygen reacts. Chlorine, yep, it's very, very reactive, just like fluorine. Argon doesn't want to react at all, just like neon. And so when he did that, he started to see these patterns. So these orange elements have a lot of the same properties. These light orange elements have a lot of the same properties. This column has a lot of the same properties. I know they're different colors. We'll get to that. This column had a lot of the similar properties. So every column or group has similar properties. And all the noble gases act the same. They have similar properties. So that's what he saw repeating, and that's the information he used to make his periodic table. All right, let's go ahead and let's add a little bit to our notes. All right, so I added groups or columns. They're vertical. Elements in the same group have similar properties, including the same number of valence electrons for group A. So group A means that we're skipping the messy middle transition metals. So this is group 1A, 2A, 3A, 4, 5, 6, 7, 8A. Or in other words, it does for everything except the messy middle transition metals because they can have multiple charges. Rows or periods are horizontal. Elements in the same row have the same number of orbitals. So if we draw the Bohr diagram, hydrogen has 1 electron and it fits in the first orbital. Helium has 2 electrons. It fits in the first orbital. Lithium has 3 electrons, so 2 fit in the first orbital, 1 fits in the second orbital, so 2 orbitals. Beryllium has 4 electrons, 2 in the first one, 2 in the second orbital, 2 orbitals. So all the elements here in this row or period have 2 orbitals. So look at cesium. How many orbitals does cesium have? 6, because it's in row 6. Cesium is a lot like which other element? Well, even if you don't know anything about cesium, you can say, well, it's a lot like francium, rubidium, potassium, sodium, lithium, and even hydrogen because they're in the same column. Mendeleev. He used groups and periods to organize elements. He organized based on atomic mass, although today we use atomic number, and we're going to write some more about him. Mendeleev's periodic table could also be used to predict the property of unknown elements. This is what makes it really amazing. In organizing the elements by their atomic masses and other properties, Mendeleev predicted the existence of elements that had yet to be discovered. He was able to do this because the table revealed certain patterns in atomic masses within a period. Likewise, he was able to predict certain physical properties of elements within a group. So he not only predicted and said, ooh, there's going to be an element discovered and it's going to fit right here. And he described it and he was right. So he was able to predict specific properties of elements including about what the mass number was, how reactive they would be, what they would look like before they were even discovered. So that's crazy impressive. And that's what makes his periodic table so amazing. So he left spaces or gaps in his table for the elements that were not yet discovered. He knew the properties, approximate mass, and how those elements would look. So it's really impressive. He could say, well, something's going to go here, something's going to go there, and like this. He said, well, we're going to find an element, that has a mass of about 44, and it's going to react kind of like aluminum. It's going to have 4 orbitals, which they didn't know about then, but it does. So it's pretty amazing that he could do that. Mendeleev predicted the properties of germanium about 17 years before this element was discovered. Mendeleev was able to use the same trends to correct data that were incorrect because of the limitations of technology at the time. Because the table correctly identified periodic trends and could predict new elements, Mendeleev's table was adopted almost universally. His ability to predict the existence of germanium, Ge, and its atomic mass and other properties swayed scientists to accept his tool that is still used extensively today. So he didn't have microscopes, he didn't know about electrons, and yet he could still do this. It's really impressive. It took many years for Mendeleev's ideas of the periodic table to be accepted. Today, the periodic table is the central organizing tool of chemists. Mendeleev left a space in what is now Group 4A. Based on the properties of the group, Mendeleev was able to successfully predict the properties of the missing element, which turned out to be germanium. The periodic table of today has elements arranged by atomic number instead of atomic mass like Mendeleev did. Take a look at today's periodic table. Notice that the elements are arranged according to increasing atomic number. Remember, atomic number is the number of protons in the nucleus of an atom. Mendeleev was not far off by organizing elements by atomic mass because atomic mass generally increases as the atomic number increases. So again, Mendeleev used mass because they didn't know about protons. We use the number of protons. They go up in order, really nice. And that's what we use to organize the periodic table today. Mendeleev's periodic table was developed before scientists fully understood the structure of an atom. Okay, personally, I'm not big on making students memorize what scientists do what. It's just not my thing personally. But this guy, super impressive. The periodic law states that if elements are arranged by atomic number, there will be repeating patterns of the properties of elements. Okay, so periodic law states that the properties of elements are periodic or reoccurring or repeating and are correlated to atomic number. So, in other words, the periodic law states that if elements are arranged by atomic number, which they are in the periodic table, then there will be repeating patterns of properties. So we're going to see that the elements are like other elements, and it's a pattern. And that's where it goes back to groups. Elements in the same group have similar properties. Well, we call that the periodic law. The modern periodic table is arranged in groups and periods as well as Mendeleev's. The elements that are found in the same vertical group all have similar properties. Properties do repeat as you move from one horizontal period to the next. This repetition of physical and chemical properties across the periods of the periodic table is called periodic law. So let's look at number of valence electrons. So they're saying 1 valence electron, 2, 3, 4, 5, 6, 7, 8, 1 valence electron, 2, 3, 4, 5, 6, 7, 8. That's what they mean by repeating. So this whole group has 1 valence electron and therefore similar properties. It is possible to predict the physical and chemical properties of elements based on their location on the periodic table. The periodic law allows us to predict the properties of elements conveniently. And this is the last slide. I'm going to get cut out of time, so go ahead and make sure you review this one once I get cut out of time, and ask me questions if you got them. So the modern periodic table is arranged similarly to early versions. Dmitri Mendeleev was one of many early scientists who tried to characterize matter. He organized known elements according to the atomic mass and predicted the existence of germanium, which was discovered 17 years later. The modern periodic table is organized by atomic number and organized into